Dear student, myself Dr. Satyam Kumar, Assistant Professor of Mathematics, Government PG College Chunar. We are here to discuss an important topic called differential equation. Before we discuss this topic, we will discuss some uh, terms. First one is differentiation. And second, equation. Anyone can say about what is differential equation and what is differentiation and what is equation? As we know that differentiation is instant rate of change of dependent variable with respect to independent variable. Suppose y is equal to fx is a function in which y is dependent variable and x is independent variable, that is y depend on x. Then differentiation of y with respect to x is denoted by d dy x of y and it is equal to limit h tends to 0 f of x plus h minus f of x upon h. Similarly, we can define higher order derivative. And what is equation? Equation is relation between variables. Variables may be one, maybe more than one. Suppose x and y are two variables, then x plus y is equal to 0, x into y is equal to 0, x square plus y square is equal to 1, x plus y plus 2 is equal to 0. All are equations. If x, y, z are three variables, then x square plus y square plus z square is equal to 3 is also an equation. Now we are going to discuss differential equation. As the name of this equation suggests that it has two terms. First is differential and second is equation. That means it has differentiation as an equation. That means it has dependent variable, independent variable and derivatives. So we can define a differential equation as any equation containing independent variables dependent variables and derivatives. Actually, derivative means derivative of dependent variable with respect to independent variable always is called differential equation. So we can write many example of differential equation. First one, d dx of y plus sin x is equal to 0. Second one, d2 dx of 2 of y plus d dx of y plus 3y is equal to x square. Third one, d dt of y plus d dt of x plus x plus y is equal to 0, and d dt of x plus y equal to 0. Fourth, del 2u by del x2 plus del 2u by del y2 equal to 3. Here x and y both are independent variable. U and v, u actually, sorry, u is dependent variable. Del u on del x plus del u on del y plus v equal to x square plus y square, and del u upon del y plus del v upon del x plus u equal to x into y. These are some example of differential equations. In definition of differential equation, we have three terms: independent variables, dependent variables, and derivatives. So, the number of independent variable may be one or more than one. Also, the number of dependent variables may be one or more than one, and derivatives are maybe higher order derivatives. On the basis of number of independent and dependent variable, we can classify the differential equation as follows. First one is ordinary differential equation. We write OD, ordinary differential equation. As you know that ordinary differential equation has ordinary differentiation. Ordinary differentiation means it has only one independent variables. Ordinary derivative means it has only one independent variables. So, in a differential equation, having only one independent variable is called ordinary differential equation. For example, here y is dependent and x is independent, only one independent. Here x is independent, here t is independent, only one. So 1, 2 and 3 are ordinary differential equations. And second one is partial differential equations, PDE. See these two equations. In these two equations, x and y are independent variables. Here x and y are independent variables. Number of independent variables is more than 1, and hence partial derivative occurs here. That means a differential equation is called ordinary partial differential equation if it has more than one independent variable or it has partial derivatives. So we can write a differential equation having more than one independent variables is called partial differential equation, or it may also define any equation, any differential equation having partial derivative is called partial differential equation. On the basis of number of independent variables, here independent variable is 1, so it is ordinary. Here number of independent variables is more than 1, then it is partial differential equation. What about dependent variables? See difference between equation 1, 2 and 3. 1, 2 have only one dependent variable, that is y. But 3 has two dependent variables, x and y. In these two equations, here u is dependent variable, which is 1, and here u and v are two dependent variables. In this situation, 3 is called simultaneous ordinary differential equation, and 5 is called simultaneous partial differential equation. So we have following sketch. First one is differential equation. It has independent variables plus dependent variables plus derivatives. If number of independent variables is equal to 1, then it is called ordinary differential equation. If number of independent variables is more than 1, then it is called partial differential equation. And also, an ordinary differential equation, if dependent variable is more than 1, then it is called simultaneous ordinary differential equation. Similarly, if dependent variables is more than 1, then it is called simultaneous partial differential equation. Also, on the basis of number of independent variable, dependent variable, these are the classification of differential equations. But differential equation have derivative. So on the basis of order of derivative, we can also classify the differential equation. We will discuss the classification of differential equation on the basis of order of derivatives in next class. Thank you.